In the last video, we graphed a trig function y equals 3 sine x minus 4 cos x. But in this lesson, we're going to use that same auxiliary angle method, not to graph a function, but to solve an equation. So you'll notice that this one looks really similar to our last example, but instead of having y equals all of this, it equals -2. And we're trying to solve it across this domain here. Now, the first bunch of steps that we used for our graphing are exactly the same when we're solving equations. So first step, we can go ahead and find r, and we've got the same numbers here, so it will be familiar because it's a lot like our last example. We've got the square root of 3 squared plus -4 squared, or you can just write 4 squared knowing it will be positive anyway. So our r value is a nice round number of 5 again. Now instead of writing y equals, because there's no y here, in this situation we can just go ahead and say, all right, let's choose one of the 4 forms. I'm going to choose the same one that we just used, x minus alpha, but you could use any and your answer will work out. And I'm going to expand it out. Now I've got 5 lots of cos x cos alpha plus 5 lots of sine x sine alpha. So I don't put the brackets in, I just jump straight into the expansion. Plus 5 sine x sine alpha. Now we need to equate the coefficients of sine x and cos x just like we did before. So the answers will be the same, and you'll see that this working is the same as what we had. We say here there's 3 sine x's. How many sine x's have I got here? Well, here's sine x. I've got 5 sine alpha of them. So 5 lots of sine alpha must equal 3. And here I've got -4 cos x's, and here I've got 5 cos alpha of them. So 5 cos alpha must equal -4. So then sine of alpha is 3/5. Cos of alpha is -4/5. So just as we saw before, this means that we're going to be working in the second quadrant. And that's because sine is positive and cos is negative. So then to work out our related alpha, we've got a choice. We can find the inverse sine of 3/5, or we can find the inverse cos of 4/5. And we just did that one, so I remember that we had 37 degrees to the nearest degree. But when we put that angle into the second quadrant, what we get is 180 minus that, so we get 143 degrees. All right, so now we can change our question. This is the equation that we were given, and we've just reasoned that all of that actually equals all of this, but we just didn't quite know what the alpha was, but we figured it out. So the next step is to rewrite your equation, but don't write this part that we had on the left-hand side. Instead, we're going to write this. 5 cos x minus 143 degrees is equal to -2. Okay, what do you think you would do next? We're trying to get the cos part by itself, so let's divide both sides by 5. Now you can write it out again, or you can be a bit cheeky, cross that one out and put it down there just to save yourself a little bit of time. Okay, so the cos of something is -2/5. Let's think about quadrants. And in fact, let's think about what's happening here. If this is our domain, then what will be the domain of x minus 143 degrees? Well, I've just subtracted 143 degrees from this, so I need to subtract it from there. And I need to subtract it from here. Goodness, what am I going to get? Minus 323 degrees. So in other words, x minus 143 has to be between -323 and 37. Now, I've got a domain there that is 4 quadrants wide. So I know that there's going to be 2 quadrants where cos is negative. Cos is negative in the second quadrant and the third quadrant. But think about where this is. I mean, if we just think about what our number line looks like here, first quadrant goes from 0 to 90. There's our second quadrant, third quadrant, fourth quadrant. We're used to thinking, okay, we're looking in here for second and third quadrant. But actually we want an answer that's somewhere between here or so, 37, and way down this way. So in fact, our second and third quadrant answers need to be right down here. So that tells us that we need to find our usual second and third quadrant answers and subtract 360 degrees from them to get the ones that we want. Now, how do we do that? Well, we need to find the related x minus 143 degrees. Now, why is that? Well, think what you normally do when you're finding an angle. and you know it's in a particular quadrant, say the second quadrant. Normally you find the related first quadrant answer by just taking the inverse sine or cos or whatever of that angle and leaving the negative off it, saying, let's find the related first quadrant answer of that. And then we can put it into the quadrant that we want by subtracting it from 180, adding it to 180, or one of those sort of processes. So here, we've got to do the same thing. We need to find the cos of something is negative 2/5. So if we find the inverse cos of 2/5, that will give us what we need. Now, when we were graphing, we were happy just to round this off to the nearest degree. But when we've got multiple things rounded off and we're adding and subtracting them, we could make a mistake. So we need to actually go back here and get this 37 degrees into our calculator. Inverse sine 3/5 is 37. I'm going to call that A. And as I jot it down, let's use red here. We'll call that A in the calculator. We'll call this B. So when we do 180 minus that, we get B, and I'm going to go shift store B and store that in the calculator as B. Okay, now I need to find this one and store it. So the inverse cos of 2/5 is 66 and a bit degrees. Okay, so let's jot this down. It's 66 degrees and say 25 minutes, and I'm going to call that shift store C. Okay, so I've got it stored exactly in my calculator. All right, now we need to put this into the second and the third quadrant. That will give us an answer that's somewhere in here, but then we need to take 360 degrees off both of those answers. So x minus 143, we haven't found x yet, remember. We're just finding x minus 143, and it's down here somewhere. Now 180 minus c is 113.57817. I'll just round that off nice and to lots of decimal places so I can't make a mistake here. And then I need to do 180 plus c, and that's going to give me this answer, 246.4218. But these answers are quite big. Have a look at what's going to happen on the next line. If I add 143 degrees to them, they're not going to fit into the domain that I was given. I actually need these answers to be way down here. Now these answers aren't wrong, they're just not the ones that we're looking for in the domain that we're after. So we can convert them to some that will be in the domain by just subtracting 360 degrees from them. So if I take 360 degrees off this one, I actually get negative 113, which is sort of handy. I've already got that written there. I'll just be a bit cheeky and put a negative there. But if I have my 113 and I subtract 360 from it, then I'll get negative 246. So those answers were related, they just weren't quite right. Now they are. So we didn't want them here, we wanted them down there. Now, the very last step, I'm ready to just go ahead and add 143 degrees to these. But I don't want to add 143, I want to add B, because that's the exact version of it stored in my calculator. And it could be that the decimal places I've got here might add with these decimals to round up or down in an unexpected way. And you don't want to make a mistake doing that. This is a classic chance for an examiner to check that you're not going to compound your rounding error. So always save these in your calculator and add them from there. So this one's already in my calculator exactly, so now I can add B, red B, and I get minus 103, and that's 103 to the nearest degree. And the other one, I've got negative 113. Now I didn't save this one in my calculator, I could have, but I did write it down with lots of decimal places there, so I'll just chuck it back in. And I need to add B to it, and I get 30 degrees. It's actually 29.55, so it's just ticked over to be 30 to the nearest degree. So those are my two answers. The last thing that you want to do is just double check that your solutions do lie within the domain that you are given, and they do, so we're done. So quite a few steps there, and you'll need to practice quite a few of these to get familiar with solving them. Okay, another example. This one is a little bit different because we're working in radians, but we need to give our answers in exact form. So when it comes time to find the inverse cos or sine of something, we could do it in radians mode. The disadvantage though is that the decimals that get spat out, they'll be correct, but they might not be things that we could spot in terms of pi. So it might be smarter to actually work in degrees form and then convert our answers across. You'll see as we go. Now we can start by finding r. Easy first step. 1 squared plus negative root 3, or just root 3, all squared, same thing. So we've got 1 plus 3 makes 4, and the square root of 4 is 2. So our r value is 2. Now it's time to reach for one of those 4 forms. Now you can pick anything you like and it will work out. It tends to work out a lot more easily though, I think, if your auxiliary angle is in the first quadrant. So there's more chance it will be in the first quadrant, I think, if I notice here I've got cos and then I've got sine and then some minus there. I've come to notice that if I use this one, then the expansion for this one, 2 cos x cos alpha minus 2 sine x sine alpha, just has that way of sort of matching the signs up, and things tend to work out a little bit easier. As I said, it will work with any of the 4 forms though. So the next step is I equate the coefficients. I say, how many cos x's have I got? Well, I've got 1 there, and here I've got 2 cos alpha of them. So 2 cos alpha equals 1. So cos alpha equals a half. That's a nice simple one. And over here, I've got negative 3 sine x's, but here I've got negative 2 sine alpha sine x's. So negative 2 sine alpha is equal to negative root 3. The negatives cancel. So sine alpha is equal to root 3 over 2. Now this is an exact angle that I know. The cos of 60 degrees is a half, and the sine of 60 degrees is root 3 on 2. Both of these are positive, so my answer is in the first quadrant, and it just makes life a little bit easier. Now that's why I picked this one for this question, and again, you're not going to be able to pick these easily until you've done enough of them to get familiar. And if you don't pick the easy way, you'll still pick a way that works. So don't look too long and hard for the easy way. But when you find it, you can go, hey, that's nice and easy. I'm in the first quadrant. So alpha is going to be 60 degrees. Here I'm thinking in degrees, but I can transfer that then into radians. Okay, and that's the one that I want to use. So next step, I need to write out my equation, not like this. I've now put it into this form, where I can say 2 cos x plus pi on 3 is equal to negative 1. So dividing both sides by 2 gives me the cos of something is negative a half. Now that's something I know. The cos of 60 degrees is a half. I've already just thought about that right here. So if the cos of some angle is negative, then it needs to be in the second or the third quadrant. Okay, so they're the two that we're looking at. So first, find your related x plus pi on 3, the one that's in the first quadrant. Now, the cos of 60 degrees is a half, so my related angle is 60 degrees, or pi on 3. Okay, but if I want to put pi on 3 in the second or the third quadrant, I do that by, well, for this one, I do pi minus pi on 3, and that will give me 2 pi on 3. And for the third quadrant, I do pi plus my angle. And pi plus pi on 3 is 4 pi on 3. And now we're nearly there. All we have to do is subtract pi on 3 from both of our answers. So we'll get pi on 3 and 3 pi on 3, which is just pi. And there we're done. Those are our 2 solutions. Now, as with any equation, you can check if you're right by subbing your answer back in to the start. Now you can use radians if you want to, but you'd need to hop into radians mode to check. I think it's easier just to convert this in my head and say that's 60 degrees and 180 degrees. And I can literally just type in degrees mode, cos of 60 minus root 3 times the sine of 60 also, and it should give me negative 1, and it does. So I can see that that answer works. Now I can do the same thing with 180, actually just go up there and change my 60s into 180s, and sure enough, I can verify that both of my answers give me negative 1. So that's a really nice thing to do at the end of solving an equation, to check that your answer is actually right. Some of the questions in this topic can be a little bit confusing, just trying to work out what it is they're asking you to do. So in this one, they're asking us to find r exactly and alpha to the nearest minute if r is greater than 0, Alpha is between 0 and 360, so that tells us that we're working in degrees. And we're just given this, r sine alpha is 5 and r cos alpha equals 12. Now, this is a simple question, but because it's different from the ones actually asking you to solve an equation, it can be hard to know what to do first. But we can't find r. We need to go to our second step, which is to just choose one of the forms and write it out and have a look at what we know. So pick a form. I'm going to pick for this one r sine x plus alpha, and go ahead and expand it out. That gives me r sine x cos alpha plus r cos x sine alpha. Okay, have a look at that now and see if you can suggest what we should do next. What do we know? We know that r sine alpha is 5. So have a look for where that is. Here's r times sine alpha. They're in this term here. So if that's 5, then actually we have here 5 lots of cos x. And if r cos alpha equals 12, here we have r times cos alpha. So that means we have 12 lots of sine x. And we've quite simply converted this into this. Okay, so that tells us what a and b are. So now we can go back and find our r. R needs to be the square root of a squared plus b squared. So we have 144 plus 25. So we have 169, and the square root of that is 13, exactly. So that means that our r must be 13, and we have sine of x plus alpha. Now, we're not finished yet. We've found what r is. So we've got r, and to find alpha, we can come back here and have a look at our clues. We've got r, which we can now sub in. So taking this down to here, we can say 13 sine alpha equals 5. Therefore, sine alpha equals 5/13. But we need to also use this clue, which is that 13 cos alphas is 12. So cos alpha equals 12/13. Now, the reason we need to use both clues is so that we can check the quadrant. It turns out that they're both positive here, so we must be in the first quadrant. But if you just use this and deemed that it was definitely first quadrant without showing that you knew, you'd lose marks. So we need to always write down what quadrant we're in. So now we can say alpha is equal to, we can do the inverse sine of 5/13 or the inverse cos of 12/13. We should get the same answer either way. So put that into your calculator, make sure you're in degrees mode, 5/13, and we get to the nearest minute, 22 degrees and 37 minutes. So we found both parts.